Hello everyone. Today me, together with my group mates Clayton and Joanne, will be presenting about DEX Change, a scalable and decentralized exchange on Ethereum. So what's the motivations behind our project? Centralized exchanges are filled with risks. They are vulnerable to hacks, and the centralization control over users' assets, uh, when hacked, leads to massive asset losses for the users. DEX, however, reduce the risk of large-scale hacks by distributing asset control amongst the users rather than centralizing it. The need for user control and autonomy over assets. Centralizations control all the user's private keys, creating a single point of failure during attacks. DEX, however, allow the users to retain the control of the private keys, ensuring they truly own their own assets. And furthermore, we are also trying to align with decentralized finance principles of transparency, security, and user autonomy. So, our problem statement centralized exchanges vulnerabilities. They're filled with mismanagement, internal corruption, and security breaches, as seen with the MGOX example below. Thus, introducing DexChange, a solution that is user centric custody, has enhanced security over the keys and assets, as well as maintaining somewhat similar scale to centralized exchanges in terms of the trading ability. So our model is actually a hybrid model for the execution of trades. We have an automated market maker as well as an order book. The automated market maker executes on-chain on Solidity smart contracts, executes all the market orders via its liquidity pool, and keeps track of all token pair market prices through its automated market making system. And off chain, we also have an order book to help match batch orders as well as limit and stop orders. It'll also listen to the AMM for the market price updates as well for the limit and stop order matching to the market price. How do we actually calculate the market price? So the market price can be measured at any given moment using the equation on the right. So by defining a K for each token pair, anytime we need to swap out one token for another, we use the formula on the right where B is equal to A times SB over SA plus A. Every time a swap occurs, the ratio of the token pair must still be the same, equivalent to the formula you see on the screen. So what type of order types do we support in DexChange? So first we have market orders. These orders will be executed on chain via the AMM liquidity pool and the Solidity smart contracts. Thereafter, we also have additional order types where we have the sell limit and the stop limit orders. So both of these orders will be matched off-chain on Go upon either them meeting the requirements for a batch order match, or the market price being over or equal to limit order for sell limit, or the market price being lower or equal to the stop limit for the sell stop orders. Now we show the demonstration for these three orders.
Hi everyone, we will now show you how to run our DEX project. We recommend you to have 3 terminals open. In our first terminal, please open our folder blockchain order book and run the command npx hardhat node. This will set up a local testnet. And in the second terminal, in the same folder, please run a deploy script that will deploy our DEX as well as our mock token smart contract. And then run the create LP script, which will create the liquidity pool needed to demonstrate trading, as we use an AMM system that has been mentioned in the previous slides. And in your third terminal, in the folder go order book, please run the command go run main.go. This will set up the off-chain matching engine. Now that we are all set up, copy over one of the private keys that has been provided in the hardware network and import it over to the wallet in MetaMask as shown. And using this account, connect to our front-end interface. Do ensure that your wallet is in the correct network, which is the network that has been instantiated by Hardhat. All details of the network is shown above. To start trading, we need to copy over the address of our mock tokens into our DEX. And these addresses has been provided to you in your second terminal when you run your deploy script. We will now demonstrate you how to do market order. We will trade 10 Binance coin to Chia token. Since the market price of one Binance coin is 0.9, we would expect to receive 9.09 Chia token. The details of the way we do our market pricing has been explained previously. We will now execute our market orders. And expected 10 Binance coins is deducted from our account and we have gained 9.09 Chia token, which is labeled as XCH in the wallet. And the supply of our liquidity pool has also changed, and thus the market price of the Binance to Chia token has changed from 9.09 to 7.57. Next, we will demonstrate on limit orders. We would like to place a limit order on one Binance coin with one wrap ether. And as shown, the market price for this trade is 3.96. However, I want to place a limit order which has the price of 3. And since the price of the limit order is below the market price, it will not be executed immediately. As seen here, it is shown that we have one active order. Now, let's mock the scenario that some other person places a market order to trade Binance coin with wrap ether. This will change the market price to the point that now the market price of Binance to wrap ether is below 3. And now with the help of our Go matching engine, our limit order is executed at market price. We have no more active order, and because it has been executed, and we have gained 2.7 wrap ether, which is our current market price as shown. Now let's do the same demonstration with stop order. Place a stop order to swap one Binance coin with 1.98 true USD. We will place an order above the market price, 2 in this case. As such, stop order will not be executed immediately, and we can see that we have an active order over here. In the same manner, mock some market trades that will change the market price. And as shown here, we have executed the trade at market price and have received TUSD coins.
For the batch orders, unfulfilled limit and stop orders will form a directed weighted graph based on the token pairs. So then thereafter our Go algorithm will detect for cycles within this graph to identify any executable order chains. A valid order will be validated if the prices meet the conditions across each chain, such that A to B, B to C, C to A all have prices that are equal or good enough to match. Thereafter, it will match and execute the maximum volume possible within each cycle. The key benefits is that firstly, we efficiently match multiple orders in a single batch. We reduce the amount of gas fees by bundling all transactions into one single transaction. And also, we enable partial fulfillment across multiple different tokens. And we also support partial orders and cancel orders. Partial orders can be fulfilled, for example, in the batch order before, and cancel orders can be used to cancel any open orders that are currently still in the book. We'll now show you the demonstrations for these as well.
First off, let us start with a fresh environment and run the script deploy and for batch order in order to deploy all the necessary smart contracts and create the necessary liquidity pool for our demonstration purposes. In our script, we also took the liberty to create 3 limit orders which are not executable at current market price, as shown in the screen. Let me just put these orders in the top left so you can always refer to it at ease. Now, to actually form a cycle, let us create our last order. As you can see, the current market price of 15 BNB is currently 130 true USD. But we would like to make an order of 15 BNB to 30 true USD, which is not an executable order at current market price. So what will happen when I hit the execute button? Let us recap. This is the current order that our DEX has, and our Go matching algorithm will collect all the orders that are not executable at current market price and try to see if we can create a match out of it. And with these orders, indeed we can. However, not 100% of the orders will be fulfilled. For our orders of 15 BNB, only 5 BNB can be fulfilled. Thus, in our front end, we expect to see an active pending order of 15 BNB to 30 USD, our initial price. And as you can see, the Go listens to the event emitted by the DEX, and we found a cycle that can match. As such, now our active order quantity has changed from 15 to 10. And only 20 tokens are left to be fulfilled. We have demonstrated batch as well as partial ordering process. In addition to that, we also support cancellation of partial orders. Once we click the cancel orders, the active order is active no more.
We also have bonus features where we have automatic market price tracking through the AMM system. We have the ability to create tokens as well as the MetaMask integration. Lastly, this is our tech stack where we have our front-end, back-end, smart contracts, and blockchain development